Our climate is changing, and at an unprecedented rate. Extreme weather events are occurring more often and with greater intensity. As evolutionary biologists, we're trying to understand how these changes in climate will affect the biological processes that are important for the survival of life on our planet. Here in mid-latitudes, we've experienced an increase in winter storms. Part of the reason for this increase has been due to fluctuations in the polar vortex. Now, the polar vortex is a constant pattern of Arctic air spiraling around our poles, but as the planet warms, this pattern becomes more wavy and sends that Arctic air farther south. And as a result, there are periodic, uncommonly cold winter events at mid-latitudes, like this event that occurred in January of 2014. I remember reading about the impacts that this particular storm had on the US, especially in the southeast, where winters are typically pretty mild. And as I was reading, I came across an interesting image. It's a single lizard dead in the snow. Now, this is an intriguing image for me because this is the species that I've been studying for the past 6 years. This is the green anole, Anolis carolinensis. So let me take a step back and explain that I'm a herpetologist. I study reptiles and amphibians. Now, as cold-blooded animals are ectotherms, they lack the ability to produce their own internal source of body heat. And because of this, it makes them a good system for understanding the relationship between variation in the thermal environment and aspects of form, function, and survival. I use phylogenetic techniques to trace the evolutionary history of species and climate modeling to understand how the environment has shifted across that evolutionary history. I then use experimental physiology to test the limits of organismal performance in the face of this varying thermal regime. For the green anole, I've traced its evolutionary history to the island of Cuba, which is a relatively warm and thermally stable environment all year round. But during the Pliocene, a few million years ago, there was a migration event to peninsular Florida and a subsequent range expansion into the vast majority of the southeastern US. Now, as a result of this northern migration, animals were selected in these environments that were better able to function in the face of colder winter times as they moved to higher latitudes, resulting in this significant relationship between the cold tolerance of a population and the extreme cold experienced during the wintertime. But what happens, so this is a pattern of local adaptation shaped by natural selection over the course of millions of years. But what happens when climate shifts on a much shorter time frame? I was able to get at this question using this polar vortex. So in order to understand this, I went to a single site. I started at a single site in Brownsville, Texas, right near the border of Mexico. Now, typical winter times at this site are relatively mild, and lizards at this site very rarely experience temperatures below their thermal limit. But as a result of the polar vortex, there was a shift in the thermal profile of the winter, and animals experienced almost twice as many days where they encountered temperatures below their thermal limit. So here's what cold tolerance looked like before the storm hit. But after the storm, in the spring, I went back to this site and showed that the survivors of this storm were able to maintain function at significantly colder temperatures than the population was before. I then went back in the summer after temperatures had returned to normal, and after there had been a next generation born at this site. Now, this next generation had never themselves experienced the polar vortex, but inherited traits of their parents. And I found that still, animals were able to maintain function at significantly lower temperatures. This is a signature of rapid evolutionary response to a single extreme climatic event within the turnover of a single generation. Now, it's possible that this shift happened just by chance. So I collected more data from 4 more sites moving northward up into Oklahoma. And as you move northward, animals are naturally more cold tolerant and were less affected by this storm. And I was able to show that only in the southern part of this transect, where animals were not very cold tolerant and hit hardest by this storm, do we see this significant shift. So why is this important? When Charles Darwin originally proposed this idea of evolution by natural selection, he proposed it as a gradual process, one whose results could only be seen over many, many generations. But now, with data like this, we know that given the right circumstances, we can catch natural selection in the act and measure evolutionary response in real time. By gathering more of these types of data, we can have a better understanding of how life on this planet will respond to the extreme climatic events that are expected in the coming decades. Thank you.